Hello friends, let us understand angular displacement in this session. So here you can see, you must have aware of this word, that is displacement. Displacement is nothing but a shortest distance between 2 points. That is displacement. And angular displacement, whenever a word angular comes, we are dealing with a circular motion. You should know whenever the word angular comes, whether it is angular velocity, angular displacement, angular acceleration, it's all about circular motion. So the basic thing which you should know about circular motion is angular displacement. If you know angular displacement properly, then angular velocity and angular accelerations are very easy. So angular displacement is nothing but, see here, a radius. Suppose it is here at time t equals to 0, or we can say initially the end point of a radius which are going to rotate on the circle is here with, let us say it is a point A. Now after some time it comes at this point. So initially it was here, and after some time it comes at point B. So this angle which my line has covered, let us say it is theta. It is called your angular displacement. So angular displacement is nothing but a plane angle, simple a plane angle between initial point and ending point, that is a final point. That is called our angular displacement. Angular displacement is nothing but plane angle, and we know that plane angle has a dimensional formula of m0 l0 p0, that is dimensionless, because plane angle theta is always equals to arc length upon radius, and both are in meter, both should be measured in meter. So L1 upon L1, that is equals to 0, and dimensional formula of angular displacement, which can be represented as theta, is always equals to m0 l0 p0. We can say that it is dimensionless. So always remember, angular displacement is nothing but plane angle, or we can say angle between its starting point or initial point. Hello friends, now let us understand what is angular velocity. Now we had seen that if this arc starts some motion or covered some angle and stops, then it is called angular displacement, that it has covered some angular displacement. But what if it used to cover this displacement and it doesn't stop? That means that it is covering some displacement in a unit time. We can say that angular velocity is always represented as omega, and angular velocity is nothing but angular displacement per unit time. Angular displacement is measured in radian always and not degree, and time is always measured in second. So radian per second is a unit of angular velocity. You can compare this with linear velocity, that is distance covered or displacement with respect to time, or per unit time we can say, and velocity has a unit of meters per second, or we can say meter per second, and such that angular velocity is a rotational concept. Hence the displacement there is angular displacement here, and here we can give its dimensional formula. Dimensional formula is nothing but, for radian it is dimensionless, m0 l0 p0 upon, for second it is just a time t raised to 1. So our dimensional formula will be m0 l0 t raised to -1, and unit is radian per second. But what if this velocity goes on changing? The changing velocity means, let me show you that how velocity changes. See this motion. Velocity goes on changing and it increases with time, right? If it is in small amount, and then it goes on changing, and this is called changing velocity. If velocity changes with respect to time, then it is called angular acceleration. So let me show you what is angular acceleration. Angular acceleration is represented as alpha, and it is equals to angular velocity per unit time, which can be given as radian per second upon unit time, that is second, which is given as radian per second square. And its dimensional formula can be given as, we can say, t raised to minus 1 we were having for this angular velocity. So t raised to minus 1 upon again t raised to 1, and it can be given as t raised to minus 2, which can be written as m0 l0 t raised to minus 2. So they are all interrelated. First of all, angular displacement, which is theta, angular displacement upon time, that is your omega, and omega upon time, that is your alpha. That means first of all it's angular displacement, then angular velocity, then angular acceleration. Hope these three quantities are clear to you. Let us go on to our next quantity. So our next quantity is moment of inertia. For understanding moment of inertia, it is must that you know what is inertia. Inertia is a property of body to continue its motion in the direction in which it sets, or direction in which it was performing its motion initially. For that, let us consider an example of bus. If this bus is moving in this direction, and if it suddenly stops, then obviously both of these persons will fall down, and they will experience force in this direction. But the amount of force depends on the mass of body. That if mass is more, then force will be more, and they will experience a more amount of force. But this is not a case in rotational motion. This was the case of inertia. Inertia is a quantity that is for a linear motion, or we can say straight line motion. But we are dealing with moment of inertia. Moment of inertia is a quantity of a rotational motion. So consider this example of 3 hammers. You notice 3 hammers have different lengths of their handles, and if they perform a rotational motion, then you can see that a hammer with a longer handle would be difficult to stop, or we need to apply more energy to stop a hammer with a longer handle, or we can say impact of this hammer will be more, and impact of these hammer will be less because its handle is comparatively smaller compared to this longer handle. So we can say that moment of inertia, that is effect of mass during performing a rotational motion, not only depend on mass, but it also depends on the length, or we can say radius of its motion. So that's why moment of inertia, which is represented as capital I, has a formula of mass into square of its radius, that is mr square. And we can say mass is always measured in kilogram and radius is measured in meter, but is squared, so it will be meter square. So unit of moment of inertia will be kilogram meter square, and its dimensional formula can be given as m1 L2, and obviously it doesn't depend on time, so T0. Hope you have got the concept. Now our next quantity is the torque. Now let me explain what is torque using the example of door. Torque is nothing but a rotational force. Understand this. When object rotates, then obviously force also depends on its radius of rotation, or we can say perpendicular distance from the axis of rotation. Here axis of rotation of door is this. Okay, let me change the color. Axis of rotation of door is this, because door rotates with respect to these axes. And if I talk about perpendicular distance, then perpendicular distance is this. Okay. Here you can apply force on two sides. We will consider an example. Suppose you are applying force here to close this door, and you are applying force here to close this door. Okay, suppose this door requires 500 torque, 500 unit torque to close. So if you close it from here, that if you close it from this side, right, then obviously you have to apply less effort, and if you close it from this side, you have to apply more effort, because formula of torque depends on two things. One is force into perpendicular distance. So let us complete our example. So if this door requires 500 unit of torque, that means if I apply 50 unit of force to the perpendicular distance of 10 unit, then obviously my torque is 500 unit. Let us say this distance is 10 unit. So if I want to close the door from this side, from this point, if I want to close the door from this point, which is merely 2 unit away from the axis of rotation, for example, this distance is 2 unit. So our distance for the second case is 2 unit. So to make the total torque of 500 unit, my force which I have to apply here, my new force which I have to apply here, should be equals to 250 Newton. So you can see that if you are decreasing the distance, my force will increase. It's why you have to apply more effort when you are closing door with the lesser perpendicular distance, because door needs 500 unit of torque, that is fixed. If you apply force of 50 Newton here, then it will close, it will satisfy the formula of 500 unit. And if you apply force at a very lesser perpendicular distance, then obviously this perpendicular distance will decrease, then force must increase to satisfy the formula of torque, which is 500 Newton. And its dimensional formula, we can give it from its formula itself, that is force is already we know that m1 l1 t to the power minus 2, and perpendicular distance is l1, so its dimensional formula will be m1 l2 t to the power minus 2. Let us understand what is impulse of force. Impulse of force has a simple formula, that is force applied multiplied by time for which it is applied. It means impulse of force depends on two things, one is force and another is time. Now we can take a simple example of a syringe. Impulse is if we give it a short pin, then it is an impulse that you can feel. And if time is less and force is more, then also we can say it is an impulse. And if you apply it to for the more time, then the impulse will be a greater impulse. And the impulse depends on two things, one is force and another is time. So force has a dimensional formula of m1 l1 t to the power minus 2, and time has a dimensional formula of t1. So we can say that m1 l1 t to the power minus 1, it is a dimensional formula of impulse of force, and its unit can also be given as unit of force is Newton and unit of time is second. So Newton second is the unit of impulse of force. Hope you have got the concept. So our next quantity is surface tension. Surface tension is a very simple quantity to understand. As we know, this water when filled more than its limit, and the upper layer of water always gets stretched. This stretching force is tensile in nature, right? It is because water molecule always attracts each other, so they doesn't allow water to fall down unless and until it reach a specific limit. So this force per unit length is called surface tension. Surface tension T is nothing but force upon length, that is force per unit length, stretching force per unit length. The force has a dimensional formula of m1 L1 T to the power minus 2, and length has a formula of L1 L1 will be cancelled out, and dimensional formula of surface tension is m1 L0 T to the power minus 2, and its unit will be Newton per meter, because here force will be measured in Newton and length will be measured in meter. So hope you have got this concept. Thank you.